What's going on, everybody? This is a walkthrough for the Change in Environment 3.4 and 3.5, I believe. So we start off by looking at what is the natural and predictable change in the freshwater ecosystem. And if we go to the McGraw-Hill reading, we can just easily see that the process is called aquatic succession. And that is just how freshwater ecosystems change over time. And as we go through the chart, we can see that the aquatic succession begins with a body of water. Over time, it's being filled up with different types of sediments, which are just like soils, dust, dirt, maybe pieces of clay, and then also various organisms inside the ecosystem, inside the pond itself. And as they contribute to the sediments that build up, eventually we have a different ecosystem that is basically just soil and land, but it is filled with nutrients. So we have this same thing here. So what factors or changes might affect the aquatic ecosystem? This could be like a number of things. Different types of like weather, different pollution, maybe human activity. All these things contribute to this pond changing in general. If we had a pond at Madison Park, there could be a number of things that led to the change. Here's a quick video, and it's basically the same video that you would see here, just a little bit more in depth. So what changes occurred to the aquatic ecosystem in this video? The main changes that occur are organisms die and sediments build up. Those are the main changes that happen. And how does the final ecosystem differ from the initial? So how does this ecosystem differ from this initial? Well, if you look at it, you can see that this is a land ecosystem with soil and dirt, and the initial one is a lake or pond ecosystem with water and aquatic creatures. Moving on to the 3D thinking, constructing an explanation of how changes such as the buildup in soil could affect the populations of organisms in the ecosystem. Some of those organisms are going to die, and some of them are going to move on to somewhere else. So fish, for example, they're not going to be able to go any place. As this sediments fill up, they're just going to run out of space, run out of food, and they're going to die. Whereas different organisms, such as maybe different plants or frogs, other things that don't need the water specifically, they can probably just move to another spot. And then we go on to describe a dynamic equilibrium. And a dynamic equilibrium let me see if this is the correct one. A dynamic equilibrium means it is an environment that it's a dynamic that is sustainable, but there are changes going on. So I'm just trying to look for that. Dynamic equilibrium is right here. So it's a balance between different parts of the ecosystem. So they do change, but for the most part, they stay pretty consistent. And looking at this photo, how would we describe what's happening and how might that affect the population of deer in the forest? The fire itself could kill the deer and the deer population, but if it doesn't kill them, let's say the deer move somewhere else and get away, when they come back, their food sources will be reduced, their shelter will be reduced, and it'll be some time before more food is and more resources are able to go back to normal to support the deer population. So that's just like a quick run through of 3.4, 3.5. Pause the video, make sure you get things written down. Turn it in. Let's get that A.